Hello and welcome to the second of my technical tips. This one's entitled Density. Start measuring as soon as possible. So density measurements should be taken on samples from a project as soon as possible and ideally analysed and measured using multiple methods. Now, I've worked previously as an exploration geologist out in the field for many years, and the focus with drilling and the focus with sampling has always been get the core out, get it analysed, report the results to the market, try and make some money. However, a density measurement procedure should be introduced as part of your standard core handling routine. It can be introduced relatively easily, and once instated, it's got minimal cost or time implications. Now, the reason for wanting to understand density is that deposits are defined by both grade and tonnage. So variations in density are as important as variations in grade, spatially across lithologies and mineralised zones, and have as big an impact on total contained metal. So the ultimate aim with density measurements is that you should be able to model the density across the deposit with the same sort of spatial understanding and confidence as you can the grade. In most deposits, there isn't really an acceptable or suitable average global density. Mineralogical, chemical and porosity variations are the principal controls on bulk density, and these vary widely and independently across a deposit. So the best way to improve confidence in contained tonnage is 1. Take a large number of measurements across the ore body, representing all the lithologies and mineralisation domains. Now, in this instance, a large number means a minimum of 10% of the samples that you would send for assay analysis for use in grade estimation. So if you're using 10,000 assay samples to estimate your grade across the deposit, that's 1,000 density samples. And in my opinion, that's a bare minimum. 2, you are ideally measured by multiple methods. This will allow you to compare, do some statistical analysis, and avoid potential method bias. And the third one is take samples on multiple scales, multiple sizes. This avoids bias from smaller samples and accounts for the nature of the rock on different scales, and incorporates changes such as mineralogy and void content. And as a final comment, be aware of the impact of water content and ensure that you define your density as dry or wet, or even better, quantify your water content in weight %.